Okay, so I'm going to show you part 2 first. So assuming, right, you couldn't do your part 1. So again, go and color the triangle PYZ. If you color the triangle like what we did for EMATH just now, you will see a common angle. Okay, so for example, you manage to find the common angle, then it's like, I can't find one more angle for my AA. So let's say you couldn't do that. So if you couldn't do that, right, do you skip part 2 or not, right? You don't. So you carry on with your ratio. So I'm going to do part 2 first, in fact. So remember just now in the previous question I was saying, right? If the two triangles are similar, you are going to stack them up. You try to stack them so that you can write the ratio. So I'm going to do the stacking first. So I kind of standardize my ratio. I standardize the way I do it. So I usually will do my first 2 alphabet. Then I will do my last 2 alphabet. Then I will do the first and last alphabet. So my way of doing ratio is very standardized. So I standardize for all my similar triangles, so I don't make careless mistake in my ratio. Because if I make the careless mistake in my ratio, right, I cannot prove already. So after I come up with my ratio, so just now for the EMATH part, the ratio will help you with some calculation. So in this question, the ratio will help me to prove this. So where is it in your ratio? You got to check for cross multiplication. You check for cross multiplication. Any one of them can give you the cross multiply. So PZ times, did I write wrongly? Okay, let me check. Did I write wrongly first? Yeah, I wrote one of them. No, wait. Okay, I didn't write wrongly. PX times YZ. Yeah, it's here. So if you write out the ratio properly, right, you look carefully, it's very messy because there's a lot of alphabet. If you look carefully, right, the cross multiplication should get you the proof. So if you fail to prove the similar triangle, you go ahead and write the ratio. If there's nothing wrong with your ratio, some amount of cross multiplication will lead you to the proof. So again, it is linked to each other. Okay, so can you see it this way? Similar triangle will have ratios. The ratios help you with the calculation if necessary. But for AMATH, plane geometry, the ratio will help you to prove certain things like this. So then now we go back to the similar triangle. So I need to find 2 angles in the similar triangle, but yet I can only find one of them. So I only managed to find one angle, which is the angle Z. Wait, the line is too fat. So I managed to find a common angle. Glenn and Z, did you manage to find another one? Okay, Lauren, you might not be able to find the other one if you never watched the one that I sent you. It is a tangent chord theorem. So last week we went through something called tangent chord theorem. So this is a tangent. This one is a chord. So the tangent and the chord kind of created an angle. So Lauren, if you miss this, you can listen up here. So it is called a tangent chord theorem because the angle is specifically created by tangent and a chord. And the angle is a little bit out of the circle. And according to the theorem, right, this angle is the same as the one opposite the chord. So the second angle to be responsible for the similar triangle is called tangent chord theorem. So it's YPZ equal to YXP tangent chord. So you will need the AA. So with these two angles, then the two triangles are similar. So Lauren, this one later on, I can practice with you on this one. So the tangent and the chord make an angle. The angle is outside the circle, a little bit outside the circle, not fully outside the circle. And that is actually opposite the chord as well. Okay, so for the three of you, right, I need you to see that if you're doing plane geometry and there is a similar triangle, you need to relate to the ratio. The ratio will not help you to calculate because there's no calculation for this topic. But the ratio will lead you for some proving.